Hello everyone. So today we are going to start with the data structures. This course is for semester 2 MCA and the paper code is CCMCA 203. Now here, before starting with the lecture, I would like to let you aware about a few things like first of all, we need to have a basic programming skills on C++ as we might have knowledge on C. So there is some syntactical differences between C and C++. Hence, we need to be briefed up about C++ first before moving to the programming of data structure in this semester with C++. Okay, here we will have a basic concept about the algorithms and data structures. So let's start with the presentation. So here in this session, the first and foremost thing that we will look into are to explain the role of data structures and algorithms in problem solving with computers, to identify techniques to design algorithms and measure their efficiency, and many more things. We will also discuss about the what we call the complexities and the complexity graphs, the complexity notations of the various algorithms. So first we will discuss about the role of algorithms and data structure in problem solving. So problem solving is an essential part of every scientific discipline. The computers are widely being used to solve problems pertaining to various domains such as banking, commerce, medicine, manufacturing and transport. So we can see that the computers are widely used in almost every field nowadays, and to solve a given problem by using a computer you need to write a program for it. So what we need to do? We need to program, we need to automate the things so that our task in future gets easier and easier. So what is a program? A program consists of two components. The first, which is the algorithm, and the second one is a data structure. So in this paper we are going to discuss about data structures. Now this data structure is the second thing in writing a program. First we need to have the concept of solving the problem, and this concept can only be clarified and it can be illustrated using an algorithm. So let us look about algorithms. So here the role of algorithm, its emergence, from where it emerged. So the word algorithm is derived from the name of a Persian mathematician Al-Khwarizmi. This Al-Khwarizmi was the name of the scientist or the mathematician behind whose name this algorithm was given. Now what is an algorithm? An algorithm can be defined as a step-by-step procedure for solving a problem. This is the main thing what we need to know. To solve any given problem, we need to identify the various steps that will guide us to solve the problem. Now, an algorithm helps the user arrive at correct result in a finite number of steps. So here we will have a definite number of steps which will give the solution of our problem. And what the various properties are? The various properties of algorithms here, they are listed: finiteness, definiteness, input, output and effectiveness. The first one, finiteness. What is finiteness? This finiteness defines the steps which are fixed in nature. Fixed in nature means to solve any given problem, we will have a fixed number of steps. It may be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and many more. Then the second one is definiteness. What is definiteness? Definiteness means unambiguous nature. Means suppose our algorithm have 5 steps, then in all those 5 steps, none of them will have similar nature of working. Means all the 5 steps will be completely different, completely unambiguous. The third one is input. Yes, definitely. Any program, any algorithm will work only when some input is provided to them. So we need to provide a set of inputs for an algorithm or for a program to get executed. Then we have the output. So on the basis of the given input or the supplied input to the algorithm, to the program, there will be some output, some result, which is the point number 4, that is output. And effectiveness. Effectiveness defines the complexity level or the efficiency of any given algorithm. So how efficient your algorithm would be to solve your problem. Then the next, so a problem can be solved using a computer only if an algorithm can be written for it. And in addition, algorithms provide the following benefits also. So what are those benefits? The first one, an algorithm helps in writing the corresponding program. It helps in writing the corresponding program. Now what is the corresponding program? The same program which we are going to solve by taking the steps of the given algorithm. The second one, an algorithm will help in dividing difficult problem into a series of small solvable problems. So we will discuss later about this, that divide and conquer approach. The next one, it makes decision making process a more rational one. Means it rationally defines any given problem. And it also helps in making the process consistent and reliable. So we have the data structures. So after algorithm, we have the second part, which was the data structure, which will define the code segment, the idea of writing programs. So before writing programs, we have to identify the things, the syntactical rules and the conceptual parts which will define our data structure. So here different algorithms can be used to solve the same problem. Some algorithms may solve the problem more efficiently than the other algorithms. Hence, an algorithm that provides the maximum efficiency should be used to solve the problem. And one of the basic techniques for improving the efficiency of an algorithm is to use an appropriate data structure. So what type of problem do we have? How we are going to solve the problem? It completely depends on the technique, on the method that are applied to solve the problem. So what are data structures? So data structures is defined as a way of organizing the various data elements in the memory with respect to each other. So we have many elements. To store all those elements, we require memory locations, and these memory locations are available in computer. So we need to identify those memory locations by any of the means, and these means are nothing but they are the data structures. Data can be organized in many different ways, and therefore you can create as many data structures as you want. So we do not have any limitations on creating data structures. There are many ways also in which we can create different types of data structures. Some of them are here listed below. So we have array, linked list, stack, queue, tree, graphs. So they are commonly known as data structures. Now what type of data structures do these are? We will discuss later in this session. The use of an appropriate data structure helps improve the efficiency of a program. And the use of appropriate data structure allows us to overcome some other programming challenges. No? Other programming challenges, like we have many more things which affects a program apart from the algorithm and the data structures, like the level of complexity of a given problem, how complex the given problem is. The next one, creating standard and reusable component. So whether you are going to create a component, a program, a software which has a reusable part, or it is a standard component or a standard software. The next one, creating programs that are easy to understand as well as maintain. So here, as we might be having idea about software development or software engineering, where we might have studied SDLC. And this SDLC, we have a phase known as the maintenance phase. So if you are developing a software, you must also maintain the given software by providing maintenance. That is, your software might be having bugs, but after deployment it may function abnormally, or it may have some issues on the target machines which you have to give support on. Now here we come on the slide which gives us a brief description about the different types of data structures. So here, what are those? So during the first categorization, we will have the major part, which is the primitive and the non-primitive type of data structure. This primitive and non-primitive type is almost as similar as the various types of data types that we study in different programming languages, like C, C++, Java, C#, and many more languages. So in case of a primitive type, we have the basic data types like the integers, the characters, the floating point numbers, and double, etc. So these are the basic parts of a program, and we generally use these data types or data structures in our programs in day-to-day life. Now the major thing that we need to consider is the non-primitive types, which are in the form of array and list. This list is nothing but it is a linked list that we already know. So here in categorization part, we have made array at the one end and a list at the other end. This signifies that this array is a static data structure and list is a non-static, that is a dynamic data structure. And what is static and dynamic data structure? Static data structure signifies that whenever you program, you have to allocate memory for your variables before compilation time. That is, during the compilation time, you must have been allocating memory for all the member variables. Whereas in case of list, that is in case of dynamic data structure, we need to only define the member, and its memory will be allocated as and when it is required. That is, the program will be in its execution state, and if some other variable comes for storage, it will be first allocated in memory and then it will be stored. Similarly, if we move down, we have further categorization in case of lists. We have linear list and we have non-linear lists. In case of a linear list, we have the accessibility of data members which have been stored within a data structure. So linear and non-linear accessibility signifies that if we have a data structure with 5 elements, then all those elements will be accessed one by one in case of linear data structure, that is all those data structures which are based on array, whereas in case of list or linked list, that is of non-linear nature like trees, graph, all the elements or the required element can be accessed in a random manner, that is in a non-linear manner. We need not traverse the entire list before moving to a particular element. Here we have classified the linear lists as stack and queue, and non-linear lists as tree and graph. However, this stack, queue, tree and graph can be implemented using both an array as well as a linked list. If they are implemented using an array, they are known as static data structure, and if they have been implemented using a list or a linked list, they are known as dynamic data structure. Next, we have the techniques for designing algorithms. We have two major techniques to design an algorithm, that is the divide and conquer approach, and the second one is the greedy approach. These two algorithms, by the name itself, suggests what type of algorithm they are. So first, let us take a closer look on the divide and conquer approach. So divide and conquer approach is a powerful approach for solving the conceptually difficult problems. This approach requires you to find a way of breaking the problems into subproblems, solving the trivial cases, and combining the solutions to the subproblems to solve the original problem. Means, in case of divide and conquer approach, we divide the complexity level of a given algorithm, a program, a process into different parts. We solve those different parts one by one and then combine the solutions to get the actual result or to get the actual solution. Now next we have the greedy approach. Greedy means lalchi. This algorithm itself says it will always try to maximize the things. So here the algorithms based on greedy approach are used for solving optimization problems, where you need to maximize the profits or minimize the cost under a given set of conditions. So in both the cases, either you need to maximize the profit, that is the performance of an algorithm, or you need to minimize the cost, that is the availability of resources, the expense incurred on the resources. Now some of the examples of these optimization problems are, the first one, which we will have a closer look in the later sessions, that is finding the shortest distance from an originating city to a set of destination cities given the distances between the pair of cities. So this problem is commonly known as the shortest path problem, and in case of networking also it is the shortest path routing. The second one, to find the minimum number of currency notes required for an amount where an arbitrary number of notes for each denominations are available. This one, the second one, that is the currency problem, is somehow like this. Suppose you have 10,000 rupees. You do not have any resource or bag purse to carry it. All those currencies are in the denomination of, let's say, 10 rupee or 20 rupee notes or some coins. So for a 10,000 rupees, you will have large amount of money, let's say a half kilogram or 1 kilogram or so. If you have currency in the form of, let's say, 500 rupee note, 100 rupee note, then it would be much easier for you to carry the currency. So this is the problem known as the optimization problem. And the third one, selecting items with maximum value from a given set of items where the total weight of the selected item cannot exceed a given value. So this problem is as similar as the problem mentioned in the currency one, with only one thing, that is we have a limitation, that is it cannot exceed a given value. Okay. So here we have a question. So the technique, the dash technique involves selecting the best available options at each step. So you can answer this one. Just now we have studied, that is the greedy approach. So the next one we have the recursion. So what is recursion? So recursion refers to the technique of defining a process in terms of itself. It is used to solve complex programming problems that are repetitive in nature, is implemented in a program by using a recursive procedure or a function. What is a recursive function or a procedure? So a function or a procedure that invokes itself is known as a recursive function or a recursive procedure. It is useful in writing clear, short and simple programs. So it is a common situation, recursion. We have studied in our programming also n into n minus 1 upon 2 like this. So the same one, we have sum is equal to n plus sum of n minus 1, and then we are returning the sum. There is some issue in this solution. What is the issue? You just find out. I'll tell you. Here, if we are going to perform n plus sum of n minus 1 and then we are going to return this s, this program will run infinitely. Why it will run infinitely? Because we are not specifying any terminating conditions. So we need to specify the termination. That is, if n is equal to 1, then return 1. Otherwise, you return the recursive nature. Then we have the efficiency of the given algorithm. So we will discuss this efficiency in the later sessions. We have also to discuss the asymptotic notations and the various graphs. So we will have closure loop on all those in the next lecture. Thank you so much.